Let's get a real mouse, shall we? Let's get a real mouse. New hotel? No, this is the hotel I've been in for like 5 days. I'm going somewhere new tomorrow, though. We'll give it a few minutes for people to show up, and then we will start attacking. Do tell. If I tell, then stalkers will end up where I'm at. Or something. That's no good. Hotels must be fairly inexpensive. They're not as inexpensive as I would guess. Like they're not expensive, but nobody's really dropping their prices super low from what I've seen of like reasonably nice hotels. I don't know if like, you know, nasty places are really cheap. So generally, I'm just continuing to travel around the area where I am. So no surprising different travel, but just, you know. What do I snack? It's these like gummies that were in the hotel lobby. They're not very good. What I do yesterday that the VOD is missing, you know, we were talking about consulting a little bit, and I just didn't want that on the record, I guess. I don't know. Hotel food is never good? That is false. I don't know where you live, but hotel food is often quite good. If it's a good hotel with good restaurants. It's never cheap. Well, that's probably true. What are we attacking in the back end? I'll start explaining that in like a minute. The hotel waffles that you pour the batter. But that's just like waffles at home. Okay. Okay, in general, with the back end of the compiler, it's gotten a little messy over time because I was focused on the front end, because the front end was the part that was actually really complicated and gnarly because that had the type inference in it and polymorphism. And those two things together were gnarly, although I've managed to simplify them quite a great deal beyond how they originally worked. Now, that sort of left the stuff that writes out the object files to get increasingly nasty over time, especially because, after I wrote the initial bit of it, someone else on the team was writing a bunch more, expanded on sort of the thing that I'd started. And, when I start programming, I don't really introduce abstractions too early because I've been bitten too often by that. So I do things kind of low level, and then I say, okay, I'll factor it out into the proper function later on. And I let that go a little longer than I normally would just with the regular backend that wrote machine code and stuff, because I wanted to make sure it went fast and all these things. But then when, other people on the team started doing, debug output code, the way that I had done the rest of the backend stuff, just the fact that it was multiplied out and had so many more concepts, it just ended up with a lot of copy paste because the abstractions weren't there, and because I was not working on it, the abstractions were not introduced, right? If I had been doing this new debug output code, I would have by then finally factored things around, and that didn't happen. So thing number one is I want to clean that up. But while looking at it, for example, I talked about this in the last stream, but there's this write type info stuff that happens, for example, when we're outputting code view, but also for Dwarf. We're going to be running the code view code directly today. This thing gets called for every symbol in the program that we want to output, and for most of the symbols it actually outputs something. And what I said was, I sort of gave this spiel in the last stream that this is the kind of thing that happens when one person doesn't write a large program, right? So I look at this and I'm like, wait, most of this is completely unnecessary, right? So we don't have to do most of this work because the compiler is set up in this other way, and this other thing would be better. It would be faster and have a smaller file size. To use the compiler's own type tracking system that already exists to know whether we wrote the type info or not. Now, my belief that this would work, maybe there's a possibility that it's based on a misunderstanding that I have. I think that something's a certain way and it's not, and I will find that out tonight and then be sad. But probably it is an example of just what I said yesterday, which is what happens on a team when people don't have perfect knowledge of other parts of the system, right? This is just kind of what happens. And it's very important to watch out for it and to be vigilant for this kind of thing and fix it, right? Now, fortunately, I don't think it's going to be too hard. It should be a relatively easy substitute to upgrade this, at least the level 1 upgrade. The level 1 upgrade is just when you call this function, notice whether we've written the type before. There's a little bit of weird ad hoc checking in here that we're going to have to root out. So for enums, for example, there's a code view type index that really shouldn't be there. Does that get used for other types too? That's for enums still. So it's being done manually for enums and structs, but not for any other types. So especially not, compound type like array of pointer to struct or whatever, which are very, very common, right? So So that is like optimization number one that could happen here. And then optimization number two that I talked about, which is more about speed than anything else, is that we shouldn't have to wait till we encounter symbols to write these types out. We should just be able to blast it in a loop, which will be much more local in terms of its use of CPU and GPU, or CPU and data cache. I don't know if we're going to do step 2 tonight. I want to try to do step 1 tonight, but well, I figured I would start with just measuring some things, right? Because if you're actually make benefit glorious nation of Kazakhstan, then you should be able to measure the actual benefit. So I want to take a line of code count for the compiler. I want to put a little bit of timing around the debug symbol writing, which is going to be kind of flaky and inconsistent on this laptop, but we'll run it a bunch of times and just like eyeball average it probably. And I also want to check this. I want to add some instrumentation code that looks at the size of this debug output, right? And so our goal is to reduce any of those things, reduce lines of source code, reduce time it takes, reduce size of output data, right? We're trying to slim down. So hopefully that makes sense for people. GPU-driven compiler confirmed. Nope, not confirmed. Okay, are there any questions as we begin this? I'm going to start just by doing some easy stuff. So for example, I can do lines of code on the compiler. We're at 53272. So I'm going to put that at the top of our to-do. 53272 lines. Let's add a little bit of code. So this x64 debug writer gets called by obj writer, and I'm going to say, so before we start code view, we're going to say length before is c.length, right? We'll no check in that. And then I think it's all in there. Let's make sure. Pretty sure it's all in there. So this is going to be length after. Wow, this one's already wrong. And there's a bunch. Actually, there's a bunch of other things that I noticed that are needlessly slow as well. And I'm just going to sort of wing it. I don't think we're going to be able to do everything in terms of optimizing this. So I'm just going to kind of do whatever I feel like with an eye toward making all these things get smaller. So we're going to printf code view data size is just how big is that in the file, and we want that to go down. And we're going to use, of course, the Sokoban game as our test bed because that is a big program. How do you approach this kind of stuff from a team management perspective? I don't know. I mean, when I think about team management, I mostly think about other kinds of stuff. Oh my God, really? 6 megabytes. Wowzers. Okay. So, well, let's just put that. And this is our starting state. Boy, I am really eager to make that smaller now. Like, how frickin'... Wait, does that go... That goes into the PDB? Or does it just go... Well, it goes into the object file no matter what, right? Right? Whoops. Oh my God, dude. It's like... not quite a third of the file size. So we need to do some stuff about that. And this is, it's not quite a third of the file size in a file that is very inefficient about generating machine code. Like, our code size should be a third of what it is just for the machine code. So this is like crazy balls. We need to try to cut this down. Yeah, we need to make gains. That's what we need to do. Is it crazy to maybe decide to write a new, cleaner implementation while keeping the old one for reference? That's not crazy, but what I tend to do much more often than that is just incrementally walk the current implementation in the direction that I want it to go. Because then you can keep something running the whole time and just walk along the ISO surface of programs that function correctly. And keeping your thing functioning correctly is worth a lot in my experience. Okay. So now we wanted time as well. We'll measure code view time specifically, but then also backend time separately from that, which we already report. Okay, so add F4F, right? And this is just a kind of a messy function that returns doubles, right? I think it returns doubles, right? Let's get time, yeah. So we're just going to do that. And then here. All right. Now, like I said, time on this laptop is really inconsistent, so we'll just see 0.0641, 0.0550, 0678. I mean, yeah, let's just pick something like this, right? Like it's somewhere a little bit over 0.06. Maybe it's 0.064. I don't know. But that's 6 milliseconds, which seems unacceptably long to me. That is a long time. In fact, the entire back end, I mean, it's not that surprising that since it's writing out a significant fraction of the data, but the entire back end is only, 0.14, 0.1, maybe sometimes 0.15, right? Let's look at what those were: 0.148, 150, 159, 138. I don't. This is really not going to be super scientific, but let's just sort of take that one as somewhere in the middle representative. So it's more than a third of the actual time. So our goal is to make these numbers go down. And of course, the time numbers are less scientific, right? But data size, definitely we want that to go down. Lines of code, we want that to go down, etc. What are those numbers? Like, I literally just did. Why do people Twitch chat? Okay. But numbers only go up. Yes, that is why software is bad, because numbers only go up. When numbers go down, software is good. Okay. So let me just start doing the thing, right? So over in x64 debug writer, I happen to know, or at least it's my theory, that I can use the type info that's been output for each one of these things to register whether we've outputted that type. So this thing basically, you give it this type definition, which is one of the types in the programming language, right? And it returns an index. Like in the code view file, each type has essentially the array index of which type in the array it is, right? And so if we add a new type, we need to return the index of the new type. If it matches an old type, we should return the old type. And the issue with this function is most of the time when it should match an old type, it doesn't. And so we want to fix that without making it slower, which should be very easy, I think. Now, what am I going to do? I'm going to use a thing called type info that's on here, right? In fact, it's being used here, but we're going to use it a little differently. So now let's just put in some assertions and make sure that they hold. I'm going to assert that this is not null. And I believe it's so, I put X's in front of the index within type table. I think that's because I wanted to get rid of it for size purposes because it didn't have a real meaning. But if we really want to use it, then maybe I shouldn't get rid of it. Let's see. Index within type table. Oh, it's in the extra data. Oh, right, because it's, okay. There are two tables. There's the compile time type table and the runtime type table, because compile time type table contains types that could not exist at runtime. Okay, there we go. That's why it had X's in it, because it's like, hey, use this instead. So what I'm going to do is I'm going to assert that that's not -1. And so the first piece of difficulty might be that one of these is false for some reason, right? And then that's a wrinkle that I'm going to have to figure out what to do. But hopefully that isn't the case and we can just go. All right. Oh, it's in extra. Whoops, no, we want debug. We want debug, and we want to run x64. Debug. Debug will take a little bit to run because it's slower. Okay, well, that is sad. Although the question is, it could just be that we're calling this before we've said pack the type table. I don't think so, but let's see. Let's verify that. Okay, pack type table. No, what is it called? Type table packer. Pack data for type table. All right, so we want to break there just to see when does this happen. And then we want to see, well, we'll also break at our assertion because we know that that assertion should go off. Let's get rid of these. These are like, okay, well, we got here. So for some reason, we're trying to, so this pack data for type table, it makes the runtime table from the compile time tape table by only putting in the things that we believe are referenced at runtime. So either, oh, you know what? No. I'm using the wrong type table, okay? Because clearly we want to put in the debugging info, types for things where you might not query type of. Like that's obvious. Okay. So I want to actually use index within compile time type table. I goofed. Let's see if that goes off. It really shouldn't. Okay, that's great. We're going to run that on tests as well, real slow, and just see if any asserts go off. Actually, let's run that with -x64. If I don't do that, it uses the other back end. Any questions about what I'm doing so far while this runs? Yeah, I said greater than or equal to 0, so yes, it could be 0. So it looks like I'm clear to go ahead. We'll check back in a second. But anyway, we have this extra data. And so now, instead of doing this case-by-case thing where we say, oh, do you have a code view type index? Like, okay, there's always this choice that you have, and about where to put data. And I make this choice different ways at different times, right? So here we're using this thing called code view type index on the extra data. I don't know why that wasn't used for everything. Like, it should have been trivial. I don't think the author of this code knew that these type infos were uniqueified, because it would have been trivial to just do this. If we just put this here, then I think our output gets a lot slower, a lot smaller and faster. I'm tempted to just do that. I'm going to want to move this in a bit. So what I was saying is you always have this choice about where to store things, right? Do you like store this code view type index on this struct that's about types, right? Or do you store it locally to this code and cross-reference in some way? And really, sometimes I do this because sometimes I think it's going to make code that's faster in some way. But in this case, I don't believe that that's the right choice, because you sort of contaminate this general data structure, which is this core data structure about types, right, with information from some subsystem that it may not even care about and that may not even be active. Like, we might be writing dwarf debug data, right? So why is there even a code view type index field on this thing? So I'm going to want to move this. But first I want to convert it. We should be able to, every time we're about to return something, we should just be able to store it, right? Whoops. So, all this is the same, right? And it's very weird. like, I don't understand what's going on here because it's got this CV current index. It's like not incrementing it. But then it like, what? Like, a more hygienic thing to do would have been to just get the value of this counter and increment it right there, because you want it to just be like, get the value. So like, I don't understand why field, is that a field of the struct? Does it get incremented before it's used? I don't even know. We're going to have to look at this because that seems kind of gross. Oh, there's like a forward declaration versus a... Oh, man. I don't know. Okay. We're going to hope that doesn't break. Okay. So right now our lines of code is actually going up a little bit, but sometimes that's just like, so all of this can go away. This isn't going to shrink us by that much, but these lines of code are all going to be useless, because if you did the setup to create these, then it's already filled. So we would have returned at the top when we check the extra data code view type index, right? Okay. But in the meantime, I have to frickin' do this for all of them. So we're gonna have to change this. It's bool type code. Hope I don't screw this up or we'll break it. Oh my God. Like, it sort of confuses me. Yeah, I don't know. That's going to be fine. It's just going to be so easy for me to make a mistake on one of these. Like, yeah. All this actually... Like, see, this is sort of like hard code writing all the members and the types and stuff. And the thing is, we know what these are. And in fact, there's a function that gives you this for a type. So we could have just called that function and then said, write the code view type info for that type. And it would have been a lot shorter than like all this, right? All right. But for now, again, we're doing all this. Okay. And then if we can't handle it, we return a 0. Uh-oh. I assumed it was type. Like all this would be probably worth making a function for as well. I'm not sure if some of these are created because they're used explicitly or to like save space. Why don't we have offset type? What did that used to say? Diff that. Ref type. I don't understand why that's different. But okay. We'll deal with that later. So our lines of code has certainly gone up, but maybe the code size has gone down, but that doesn't matter unless we can also still debug the thing, or at least not crash, which we just frickin' did. So that makes me sad. Why did we just crash? Because I made a mistake. Well, we're recursively freaking out. Why? Why are we recursively freaking out? So this is members of a struct. Oh, okay. So the deal is I took out, see, I did change something important. Where is it? The actual function. Okay. So in the case that you have, for example, a struct, it used to check for the existing thing in the beginning, right? Now I actually don't write the result until the end. And the problem with this is that setting this in the beginning served as a recursion termination case when a struct has a pointer to its own type. And we didn't do that until later. Or actually, maybe did I not actually set it here? Did I neglect to set it? Wait, no, I did. Wait, I set it right here. Wait, what? So maybe I just made a really stupid mistake instead. Oh, yeah, you know what the stupid mistake is? Let's get the data and assert on it, but like not actually return if it's set. Guys, if you're going to succeed in the game industry, Don't do what I just did. All right. Now the problem here is it's frickin' U32, so we can't use -1 to mean not defined. So we'll just say that. Do you allow adding overloaded functions from the meta program? Yes. If so, how do you know when overloads are resolved when the language has implicit casts and the ability to generate overloads during compilation? The answer is if somebody has used that overload, like if somebody has picked a function from that overload, then it becomes locked. So you can only add overloads prior to somebody using it. All right. That didn't help by as much as I thought it would, honestly. So we're going to have to investigate some more. But it did help in terms of size. Like our old size was like 6.5, right? 6.3. So we saved almost a megabyte of debugging size just by doing that, which is significant. And so I would expect, well, okay. We still have yet to like verify that we can actually still debug. I might have hosed something, right? But assuming we didn't, all right. So code view DT is 0.552. We have to take it a few times, right? 526, 6, 563. I'd say 5556 is around the middle. So we save 5 milliseconds. Let's just be like after just using extra data code view type index for everyone, we went to I kind of want, the fans have shut down, so let's see, 5.4. Yeah, I mean, that's pretty good. So we've got this, right? Our output time has gone down by about, 5 milliseconds probably. I mean, again, it's very noisy, right? 155, 167, 169, 159. Yeah, I'm not really seeing. This is 1.2 seconds for some reason. We had like a 1 second stall in there. Ugh. Let's not, that's a dirty number right now. Let's not count it. It's just going to be, 5 milliseconds lower than the previous one, and it's redundant with this. And then, well, our lines of code probably went up, right? So, yeah, 53299 lines. So like I said, we're gonna hopefully get those lines back. But first, let's at least verify that we can still debug a program. Of course, I didn't test this before the stream, so for all I know, it was already broken due to other things I was doing, and then we'll be sad. So if it's broken, then I maybe want to check in since we at least compile. Well, we would run in all the tests, check in, and then revert and make sure, but hopefully we're not broken. So remember we were working on barred particles the other day? Let's go there. I was looking here. Okay. Locals. Local variables. Hey, look, we've got the local variables, most of them. We don't have the constants, but we have the local variables. They are probably correct. These all look fine. This is a level set with a level names array with count and data and all this stuff. Okay, that's good. So we got a little bit of a CPU win. We got a bigger data size win, but not as big of a data size win as I had wanted. Now, the thing is, in theory, I also have to do this same thing to frickin' dwarf, but I haven't looked at the dwarf code. I don't want to do that. I don't want to focus on keeping two operating systems not broken right now, so we're not going to change the dwarf code. We'll do that on Linux like later, right? Because once I find the ideal solution for Windows for all these things, we can like map it over there as close as possible. Doesn't that lead to weird non-deterministic behavior since functions can be compiled in any order? Yeah, but your program is correct when you do that regardless of possible order. It's like a threaded program, right? Even if you have a data race in a threaded program, your program is wrong even if it happened to read the right value of the variable. Same deal. Is there some way I could add an automated test that debug info still works? Not worth my time right now. Long term, yes, we definitely want to do that. I'm not going to rat hole this stream to do that. Okay. So I'm kind of wondering, why didn't we get as much of a win as I wanted? And that might involve just investigating the data size more. Although actually, one stat that I didn't record is like how many types are actually in the code view type table, because if it's a large number of types, then you would expect the data to be not necessarily that small. Another possibility is maybe I failed to write the answer out, right? Okay, but what I want to do, I was just saying that this is not really the right place to put this. So we're going to take it off there, and we're going to put it in code view land. And then if that works, we're going to check it in just as a waypoint. So this next thing is just about code cleanliness. It might increase the lines of code slightly again, but it won't really lead to a noticeable speed difference either way, probably. However, it does probably get us closer to being able to do version 2 of this, which is to blast all the types at once. So we're going to move this off of here, and we're just going to have an array of these things on this thing called the debug context, which I don't like that name. I want to rename it later, but probably not tonight. And I'm going to say U32 asterisk what is this? So when we have an index in the type table, we're just going to look in this slot and see what's the value. So this is code view type index per type table entry per compile time type table entry. All right. So we need to initialize that. I'm just all right. However many entries there are in the compile time type table, I'm just going to do this because, well, no, we'll leave the U32 in there just for brevity. The thing is, if you change the type, this could go wrong, but you'll at least change the cast, and you should see that. Although, we could just use new in C++. I'll just do that, and I'll just be lazy. Array new. No, I can't do it. I can't do it. Okay, so what's the number of, well, how do I know the total number of compile time type entries? I think it's that. All right. Mem set. Let's mem oxff. See, this is all kind of silly. I would rather just loop and set them to -1, but can't be bothered. All right. So anyway, this longly named thing is now going to be what we use. Let me just make sure I didn't screw anything up there, which I probably did. Indeed. Oh, no, those are just the other thing. Okay, so this is what we're going to use instead of code view type index. We're just going to do this. So this is why we were asserting that this exists, so that we could use this index. All right, here's what we'll do. We'll say if index is not equal to return index. So we're just not storing it on the type info now. We're just storing it in our own little array. But now, every time we do this, we have to say this. Annoyingly. What we really should be doing is just call some helper functions so we don't have to say this a billion times. That's going to be the next step, actually. But let's make sure this works. You wonder if malloc has ever returned null in the past 20 years. When the heap gets corrupted, it will. Okay. Don't. Well, let's just see. Let's do a debug build. I probably screwed something up. Let's actually... Dude, I hate Visual Studio. This should have been simple, but I messed it up. Index is too large. Why is that? Oh. Because, okay. See, I want this index to be called index. I want that. And then I want this. Like, it's a little confusing now because I called this indices. Whatever. We'll worry about renaming it later. Several more changes are going to happen. They're both indices is the confusion. Oh, no, not release. Do debug. Index is the name of my new band. All right, so again, like I said, this was purely a refactor. It probably does have slightly different performance attributes, but not meaningfully in any direction. So this really was just to do it. And we're just going to verify that this runs on the tests. And then I'm going to do another refactor. Actually, let's check it in. And then I want to do another refactor because it's very messy and scary to be doing all these different things for every type. So what I want to do is make a function called like code view actually write the type info. And this function will just be the header that checks the value. If it exists, return it. Otherwise, call code view actually write type info, right? And that way, then we don't have to like manually store the index every time because we call code view actually write type info and then store the value back. And that's much cleaner. What tools do you use for profiling normally? I don't know. I don't profile that much. as a beginner CS student, a lot of this stuff is way over your head. Well, I had something snippy to say about that, but I won't say it. Okay, I ran this on the wrong things. The snippiness wasn't about you, though. I'll put it that way. Okay, so this is good. Improving x64 debug writing. All right. Let's just wait till those complete. Oh, you know what? Do I have no check-ins in there? I put some no check-ins on the prints, didn't I? We're going to replace this with... I'm going to let myself check these in for a bit. Just because I sort of don't want the hassle of... Oh. Actually, let's hit that one next. So remove me is going to be our thing that's like, this is our local to do, right? We're just reminding ourselves of that. Let's make sure I didn't goof. Was a snippy remark about how he was already on a better track than others because he at least realizes stuff goes over his head or something. Not exactly. Not exactly. All right. We're just going to check this in. Next. I actually, so this is a little bit trivial, but somebody used a function that I would prefer not be used. This thing should be here, and this is basically, so we're making these different sections, and they end up in little memory buckets, and that add does a mem copy of all the buckets, and it's probably not that slow. Again, you know, we're talking about single-digit megabytes for this program, but if you don't have to mem copy it, that's just better, right? And so this says, take those buckets and put them onto your buckets, but otherwise don't touch anything. So it's strictly faster than the mem copy. And better for other reasons that will come up, maybe tonight, depending on what we do. So I just want to verify that that thing in isolation still works and that we can check it in. What did I decide to do with the S constant? I emailed George from Remedy and he was like, oh yeah, S constant isn't even used that way. Like, it sounds like that's what you would use and it looks like it reading the documentation, but what it actually does is this other thing. So I'm like, great. So I implemented a different thing and it's still not done because it doesn't totally work. You think it was mean? You think what was mean? What are you talking about? You don't even know what I was going to say. So shut your mouth. Okay. Whoa. Guys, I screwed something up. Okay, and this is a little bit scary because, okay, here's a little subtlety. I compiled tests here. I did it with the LLVM backend, but then I run it with x64 here. Okay, it's broken. So this definitely steal that I did, I think, is the cause of that problem, which surprises me. Oh yeah. I'm going to comment out the other line. Oh no, because we get a length down here. Okay, hold on. See, the thing is, after you steal the buckets, it's empty, right? So if you ask length, it's going to be 0, which is incorrect. So we get the length, and then we steal the buckets. All right. Now, last time I had that bug, it hung a zombie link.exe process. But I guess it didn't this time. We'll see. All right. Let's see. Nope. We got to kill link.exe. High quality software. Details. Link.exe. I'm glad I encountered this earlier today so I didn't have to figure it out during the stream. All right. So that's great. So I'm just going to, that was a very small change, but we'll check it in. Did I leave the old one commented? No. All right. We're not going to bother profiling that because it's not going to be big enough to notice reliably, especially on this laptop. I should probably remove the non-steal version of add, but someone might be using it still. Okay. Now, what do we do next? Well, there are a few routes. So if we want the numbers to go down, route number 1 is maybe figure out if this size really should be smaller. Route number 2 would be just do some random performance-oriented things. Route number 3 would be just clean up the code some more. You know what? I just want to clean up the code some more because we're running a line deficit now. In fact, it's probably even worse than this, right? 53307, dude. So we're like 35 lines up, which is not great. Oh yeah, okay, sorry guys. I even said I was going to do this factor next of cleaning this up, which we definitely want to do. This may be approximately line count neutral because we're going to remove some lines, but anytime you like add a new function, actually, so we're going to do this. This is the actually part, and then the right type info is down there, and then the actually part is all this stuff that does the work. All right. So that just goes up there. So down here we say Yeah. Down here we say, okay, this becomes very simple. It's like, look, did we have something in this array that already has the thing? Oh, we need to move this. Do we have something in this array that already has the thing? This is probably useless. If not, let's just do this. Right, so we say, okay, do we have this index? If so, do that. All right, well, if we don't, then and then we put it in the array. All right. Blah. And we actually could say if it's equal to f's, then open a scope and do that. I'm not sure I like that better, but you know, okay. So then this goes in the actually right. And then in the actually right, we get rid of all the times that we assign this, right? Which is where we sort of get our lines of code back. See, I don't know about this one's weird. It should be fine though. I don't know. We need to test structs again after, because I don't. This is weird. Let's just leave that commented out, because that's not. Actually, let's make sure we do the same thing. So we're just going to do this. That's the thing that we were storing before. And we're saying return that. All right. This goes away. This goes away. You know, I did all this just to undo it, but that's how it goes sometimes. Step by step, man. I don't like what? Why are we... Like, there's only 4 of these? I guess it's fine to call free if there's only 4. We're getting most of our lines back. Okay. Failed. You have failed. Oh, 1938. So next I want to get rid of these as well. But one thing at a time. Return, return. That's the name of my new programming language. Return, return. Okay. How are we doing now for count? 53286. Well, that's still higher than original, but not by a lot. Let's make sure it works. If it doesn't, surprise, I goofed something real bad. Probably the struct thing again. Oh, yeah. No, remember that struct recursion? That is definitely going to happen now. So what we could do is say that we know. It's that same recursion problem, and because we split the way that we're recording the type information. Let's just put a temporary hack in there, and then we'll figure out what to do. I am not at all opposed. We don't really want that there. That's very fragile and scary, but oh, I did it wrong. Or that's not actually the problem. Okay, let's verify that that's the problem. I think it is the problem. Oh, well, no, because never mind. Because I compiled a debug build and ran a release build. That's the problem. All right, great. Great, everybody. Just making sure it runs. Great. Okay. We don't like that hack. But I'm going to let it slide for a little bit. Because something might become apparent about a better way to handle that. I mean, we could always just pass the entry in for people who need to prevent recursion, right? Let's make a shorter name for this. Whoops. Okay, so that'll make this less ridiculous. So what we could do is here, take a pointer to this entry, and then we could pass it down to here as an argument that almost everybody ignores, except the struct handler doesn't. And then we put a comment Y. We could do that. The reason this is not a good way to do it is because we're assuming we know what value the struct code is going to put there, which is maybe not right. That said, we actually overwrite it with the return value. No, but there's not, no. I just thought of another hack, but that hack would have been bad. A more robust solution would be to use a recursion sentinel. No, that wouldn't work because the problem is that when we write the struct type, we're also writing type data that I think contains indices in it. And so we might hit that recursion sentinel and write it out as a type. Like, I'm not sure, but I think that's a danger. And so I would rather not do it. I would rather not do it. Okay, but what I do want to do, we'll come back and hit this before we check in, as I said, because there's a no check-in, but I want to try and get some more cleanup in here, because this stuff that checks like type def void, let's actually move this down, like all these little splitzers here, can probably all go away. And then like why? Like this seems really messy, like add pointer type and then return the index. Like if this is putting something into an array, I guess that's writing it into the buffer. I don't know, this seems really gross to me. But anyway, I want to do this and then simultaneously, like, oh, is this the dwarf code? Yeah, that's dwarf, which we'll hit later. Offset type code. Okay, all this stuff. Why are we writing dwarf things? Oh, because that's... Hold on. I kind of want to split dwarf and code view into separate files because this is annoying, but I don't want to do it right this second because we're in the middle of other things. Okay, code view, code view, code view. Offset type void. Where does this stuff get set? Down, what? Are these like reserved? Are these like reserved code view indices? And so that would mean that when that thing that we're incrementing must start at some range beyond those, right? So when we say CV current index plus plus, right? CV current index, okay, it starts at OX 1000. Right. Okay. This is so weird here because like these are sort of like, let's pretend this type is a struct, right? And outputting those things. But it happens for this stuff here and for arrays elsewhere. I guess those arrays are different types. Anyway, I'm not sure which to do first. I kind of want to factor this out and just go for a significant lines of code reduction, because like I said, there are structs defined for each of these things, and I can make a factored out thing that's like just iterate over all the fields of this struct. Well, in fact, we have that. It's called actually write the type info. So actually, okay, let's make sure we could debug still, right? Okay, we built release. We're here. We're going to run remedy. We've got our breakpoint inside the barred particles. What's with all the magic numbers? Those are defined by the file format specification. $128-bit Boolean. I mean, sometimes you need to make sure that you have enough digits of accuracy in your Boolean. That's just how that is. Okay, great. Actually, also, I want to make sure we look at an array because we're about to screw with arrays and stuff. So here's our particle source. Wait. Particle source. We don't have all the members of particle source. But for stuff like context, we do. See, the thing is, there was sort of a bug. I was noticing a bug on the LLVM backend about this kind of thing. I don't know. I don't know what to think about this. Anyway, we'll keep an eye out. So it seems clear that by the time we get to code view, the ability to write out structs with many fields and stuff is working fine. I think there's like some kind of bug though. I don't know. We're gonna need to look at it. Because I've definitely seen in the LLVM build as well, not seeing all the fields of a struct. That is not new. And only for certain structs. Actually, mainly for the particle source, right? Because that was what was going on last. Okay, anyway. Oh, yeah, see, okay, it's screwy. The debug output code is making bad decisions about what to output. Like here, this XY is actually probably, oh, you know, I know what it's doing. This is a whole other issue that has nothing to do with anything we're doing. We'll punt that one until later. Yeah, it's sort of what it's doing is it's seeing that there's this XY there first, and then there's a place with an XYZ over that, but it's like, oh, the XYZ overlaps the XY, so let's not really show it. And I guess that's the question, is what should the policy for that kind of thing be in the debugger? But the problem is right now I can't see Z at all because we just chose to skip it. Except why is component? Oh, because it's a vector 2, right? Anyway, Not rat hole for now. What I do want to do, because what we're about to change is this array thing, right? Oh, this is just a string, so any string is fine. I don't think we really... Constant string we can't see in debugger yet, but what... There might be strings here. There's got to be like a global string. Gameplay settings, I'm sure, has strings. What? Is it not called that? Or do we not see... It's gameplay settings. Does it not see it because it's in a different file? All right, we're going to have to look at that later, but I don't believe that that's related to what we're doing right now. Let me just find a frickin' string that's not a constant. These are all constants. How about, can I see startup variables? Oh wait, what's it? That's a type. Oh no, it's not. All right. Startup variables. I don't know why it doesn't tell all the globals to the debugger. That's a separate thing we're going to have to look at. Let's just find a breakpoint. You know, like HUD... Like, how can this be so hard? There's tons of strings all over this program. I just can't think of any dynamic string generation that we do. Oh, asset name lookup. We could break in add value folder. Yeah. So this happens at startup. It's got some variables, and we could look there. So let's do that. Okay. Folder. We're not seeing all the members of this either. Dude, I'm kind of pissed off. Did I break this? Okay, A, maybe I broke this. B, maybe it's not broken in Visual Studio and is in Remedy. Because I did see a problem before, but it didn't seem this widespread. We're going to have to, like, I kind of want to check in and then go back and see if this was the behavior. Okay, but anyway, we are able to see a string. So before we do any rollback, I'm going to go forward a little bit more, and I'm going to, because I want a code size win. So what we're going to do is fix that and then verify that it still works. What is it called? Array view 64. So here, if we actually just output an array view 64, That should be fine. Instead of all this, I think we say actually we don't even need to do this here. Nah, we'll do it here. Because in the version where we just blast through stuff, it would make sense to do this ahead of time. Offset type string equals actually write code view, whatever that was called, interp. See, we have these struct descriptions. Interp array view desc64 define type. Maybe that's not what this. We'll find out what these things are actually called. Actually, code view actually write type info. So we're going to replace all this code with just this. And this is maybe theoretically a hair slower, but it's worth the code size and complexity desync win kind of a thing. It's just way better to do it this way. Yeah, I didn't pass all the arguments. Code interp context and type. Actually, we shouldn't even call actually write type info. We should call code view write type info, because we actually want to fill it in for this. And then I want to copy that over to string. So this get extra data interp def string type info, right? Extra string index within compile time type table equals ctx offset type string. So at this point, we should never, I'm not going to remove it yet, but we should never get into that function for type def string because we set it here in the beginning. So then we can take that out of that other code and remove some if statements, right, from that loop. All right. All right, well, it appears to work. Code view no really write type. Well, I mean, yeah, actually and really and all these things are useful words in programming. Okay, so folder. Base folder, actually. Okay, so we still have this. Looks to me like it worked. Now, how do we prove that this code actually did what I claim and actually affected this thing? And the way that we prove that is by putting the wrong struct info in there, all right? So what we could do is put type def any instead of type def string. Wait, no, here. So instead of this, it's gonna think that that string is an any, and that's gonna be a disaster. Oh, I did that. Okay, so it should be wrong now. When we try to look at base folder, yep, it thinks it's an any type and value pointer. That's actually pretty weird that it's putting the 7 twice. I don't know what TBI is supposed to mean. But it's incorrect anyway, so like I don't know if we're stressing something else. So the point is, I was verifying that. So all this can go away. All this can go away. We're just going to make that a little bit more readable because we're going to do this a few times. All right. So this one is array desk 64, right? This next one is type info, I think. So we have non-leaf type info pointer, which is interesting. Do we even use that? Oh, it's in preload. Decal type info. Do we not save decal type info? All right. Decal type info. So we do mandatory lookup. See, we have all these type infos and stuff. Let's say well, it's this. Wait. No. That's not what we want. Because that'll be the type will be type, right? Okay. What we want is this has an expression. Come on. Learn to type. We're just adding code back onto our budget here, but it's fine, kinda. Okay, so we're setting that up so that actually, let's just do this, because this is what we actually want as the type definition, and that's one step faster. All right. So for this one, this stuff, which is hard-coded and will desync, in an error-prone way from other declarations, instead of doing that, so the thing that I'm giving up here a little bit is this is putting in a custom name that just says type instead of the type info star. Let's just put that here for a second. Get the name back, exclamation points. All right. So we're going to do this. Offset type ref type. And instead of this, it's interp type def type info. All right. Oh no, def and type info is what we call that. Okay, so then we're going to get the extra for type, and we're going to shove that in there. So we've got string, we've got type. I could put this down here to keep the order the same. So I think we're going to want to make a function that does this eventually, because we're going to do it like 3 times, I guess. Wait, what is this one? Context. So that's pointer to contact, yeah. Yeah, so we probably don't need to replace this one. Okay, so let's just make sure that works. And the question is, where do we... So first make sure it compiles. And then we need to break somewhere that has a type. Which entities have a type? So we could probably go back to our barred particles. Ifo, type ifo. All right. TBI to be implemented, probably getting an unrecognized type index. That's a little bit sus that I might have broken something. Did we not set def and type info? Did we not set def and type info? Oh, guys, because it's a struct. Yeah, I was dumb. I was dumb. It's fine. I was third imposter right there. All right, so that worked. Let us validate. Well, I mean, we didn't change this, but oh, well, why is our base? Okay, hold on. I expected to go to that function many times. Why did F5 one time cause us to go? I'm scared. I don't understand. We call that function like 20 times. Okay, anyway, what I was going to say was I think we can see enough of source, even though we're not seeing the whole struct, and we're going to have to investigate that. Oh, no, we're not seeing everything. See, this has an entity type in it, but we can't see it. Is there something else on the call stack? Does emitter have the same problem? Yeah, that's so weird. All right, well. Manager by type gem. No, there won't be anything there. By type guy. I think I really did break something. Entity manager has way more members than this, and I don't remember it being this bad. So I do think that the struct refactor broke something subtle here that we're going to have to clean up, which I'm fine with, honestly, because I don't like the way that code worked. Like, sometimes code is inherently a little too hard to understand, and like in those cases I would rather break it in order to change it than to keep code that is inherently a little hard to understand. But we're paying the penalty right now because it looks to me like this is a bug, and as soon as we can check in, we can roll back and verify. But in the meantime, I just want a frickin' type that I could see. Although it's even it's not even really the right thing to write out the type info struct, but I'm just preserving the functionality that was there. Let's just make one. Okay, simulate cosmetic only things. We're going to break here, and we're going to add something there just to have a type to look at. We're going to say A type is pointer to void. B type is array of pointer to A type. No, we can't do that. Pointer to float. C type is entity. All right. All right. Why am I doing debug build again? It's just going to be slow. Okay. A type, B type, C type. All right. Okay. That's not really helpful. I mean, these are probably right. Oh, wait, no, they're not right. Oh, because, guys, I'm stupid. You know all this stuff that I did to get this thing here? I actually wanted this that we had all along, all along, all along. Because we want a pointer to that thing. We didn't want the actual thing. So this def and type info is actually this, which means I'm about to go undo all the lines of code that we did to make that. Like it could have been 10 minutes shorter. Let's go back to release build, please. Please, Visual Studio. What? Okay, thank you. Some intensive calculation there. I could compile my whole game twice in the time that it took. All right, so, well, we're gonna hope that it was better now. What we are attacking right now is lines of code. We are trying to get a line of code count reduction, not just for trivial purposes, but because it corresponds to a complexity reduction of the program and just removing some fragility. Okay, these look better. These look better. And there we go. Type info tag 4, type info tag 8. I don't know why we have some names and not others here. That's pretty weird. I don't know if that worked before. Let me start writing down things. So type index. And then we need to figure out missing fields. Exclamation point. Okay, let me remove the code that I added. That was stupid. And we'll make sure that we're back working. And we'll check this in, and then we'll roll back a second and see if I actually messed this up worse than it was, or if it was just messed up already. Get the name back. Okay, I put that on the piece of paper, so we can delete all this. How are we doing for lines of code? We should be under now. 53271, right? We're one line under what we originally were. Ugh. That's fine though. As you know, as long as we don't go over. I'm surprised. I thought we would be under by more. It's fine. We have more yet to do. Oh. We get a little bit more of a win because remember I said because we're setting this and setting this, we don't need those here. Well, okay, so we just did type, right, and string. So my theory is because we set these up in the beginning. Okay, we don't need this. Actually, we'll just remove this because we'll fall through and then we'll hit the bottom of this function if it's not known, which says, hey, unhandled type. And actually, I guess we're going to do that in debug build. Okay, but see, we don't see any unhandled types there. Okay. I'm going to go ahead and remove this, being brave, and I'm going to remove this. Actually, this itself should get that same treatment. Because we have structs for all those, but I'm not going to, it's too many changes at once. I'm not going to worry about it yet. Okay. These also, I'm going to no check in these. And what we're going to do is init those. Are there any more little turdlets like this? Okay, no. We're going to init those at startup as well, so they're also going to be caught by the hey dude, right? So we have offset type string here. So now, of course, offset type void was already set up here, I think. Oh, come on, bro. Put all the primitives in a place and then use them. All right, so here we want to say, okay, here's I'm going to make a little function called set code view index of type. All right, and so we're going to go interp type def void ctx offset type void. It just does the same thing that we were poking before, right? Type def code, right? Offset type code. So we set that up at startup. It's fine. We get rid of these, and then this also does this, right? Type def string, and then oh, you know what? We're going to need another parameter. And this last one was type def type to be type ref type. Okay, so we have a debug context. Okay, So then we get the extra data. Need another parameter. It's fine. Right, and then just going to do this. Let's say code view indices of whatever is code view index. Oh, that's not really... To make a name to use it once is actually longer, probably, or the same. Okay. So set code view index of type, void void, bool bool, code code, string string, type type, and we need our extra parameter. All right, all right, all right, all right. Now we did add some code there. We added some code to save some code, so I'm not sure we came out that far ahead. Let's see. 53262. We're like -9. Oh, -10. That's great. Does it blend though? Nope. Oh, I hosed it. I hosed it real bad. What did I do, guys? Writing your programming language in your own programming language is boring and not that interesting. People... It just annoys me. I mean, I know why people who are not super experienced programmers think that's exciting. It's not exciting. It's, yes, something we should do eventually. It is like 10,000 items down the to-do list. There is no good reason to do it at this time. Okay, wait. That's not... I wanted to run this. See what the crash is. Except we're exiting for some reason. Okay, so we got a string that's not a relative string, which is weird. Okay. This should have a type info, which should have... Oh, we can't see the whole... Anyway. Okay, here's the problem. Is... So we have an index for this, as we should. It's low, which it should be. It's a basic type, so it's number 11 in the compiler's compile time type table. But it like wasn't set, and the reason is I bet we're initializing code view, and I did string too late. Yes, we're still in code view setup. Okay. Wait, no, it should be done by here. So like this didn't do the right thing. Let's see what that did. Let's see what that does. I'm glad nobody's arguing about text editors. Okay, I screwed this up. It was a copy pasta. You need to actually operate on the type that is passed to you and not just decide. Okay, that was... Let's just have faith that it's going to work and build the release build and run the release. Dude, switch! Switch! I don't know what you're talking about when you say modern software is slow. It's great. It's wonderful. Software never was better than today. Hey, look, we did it. Okay. How are we for lines of code? We're still 10 lines up or down, however you count it. Okay, so I want to check in and then figure out what the deal is with these struct declarations. Stop bullying the computer with bad software. Well, it's bad software, but it's also honestly bad hardware at this point. Like, this laptop sucks. I got it because I was hoping it would be better than the Gen 1, which it is barely, but also because I was afraid that if I got something I wasn't familiar with, it would be even worse. But yeah, this laptop's terrible. It's just like not correctly... I don't know enough about hardware to say, but it's just not correctly put together. It's a piece of junk. All right. Did I get rid of all the no check-ins? Dang it. I didn't. But that one's good because it reminds us to delete things. There's another one. Oh no, this one. I wonder if this is why structs are broken. I doubt it. Because the structs being broken was about fields of the struct. All right, so this was the hack that I put in. And the problem is if I pass this extra pointer like I was going to, it has to get passed by everyone, which is a giant pain in the butt just for a little thing. If I make it a semi-global on context, that's not good either, because you could end up with a two-stage recursion or something. Okay. Actually, no, I don't have to pass it around because it only matters. Okay. Yeah, we're going to do this. we're going to take the address of that. Okay. And we're going to do that. And okay. So I believe that'll fix our problem as well. It's a little bit neater of a solution. Still not super happy about it, but if it'll get us to check in, I'm good. Does the set of all sets include itself? Of course it does. Don't you know math, bro? All right. So we could still look at these types. I don't know why those enums don't work. It might be related to why structs don't work. This makes me think I didn't break it. The fact that enums don't all work except some of them do. That's pretty strange, isn't it? Okay. Bro. We're going to have to debug some of that. Okay, so the first step is we commit this. And then we run it back. Wait, did I? Hope I didn't add more modified files. No. Okay, so now we just need to see if it's messed up. So the thing is, bugs that are this bad are much more important. Like, you know, the mission statement for tonight was performance or line of code increases. We got some already. That's great. But big functionality problems like this, whether I just introduce them or not, are important and need to get attacked. So let me go back to actually yesterday. Are there any questions about what's going on from people who are paying any attention? Sometimes I just got to move around a little bit. Okay, so I want to know, can we see entities and do those enums work better yesterday? What is an atom? Is it an intern symbol? Sort of. It's a mostly intern symbol. Let's put it that way. A general what's going on would be helpful. I don't do those because if I did, it would make the stream very repetitive. So you could go to the VOD and watch the beginning. Or you'd probably have to skip the first 8 minutes or something until we actually started. But are we bisecting to find out when things got broken? Maybe. I'm not even sure yet. Okay, so see, here it wasn't even an enum before, so we can't tell. We need a different enum test. That's actually even less useful than what we're doing, because when it is an enum and the enum reporting works, you can actually see what that corresponds to, right? So we're going to have to look at that. Let's go to our other breakpoint in the barred particles. And can we see source? No. Okay. This was already messed up, is what we're saying. So I feel fine about this. We could look and try to figure out why it's messed up. Wow, people are just gifting subs all over the place. It's crazy. All right, so for all I know, my current guess is this is probably doing something to write out struct info that was correct once upon a time, but I did a bunch of changes to struct stuff, and it probably didn't track those changes, or maybe it was always wrong. Let's go take a look. I kind of, my eyes glazed over when I looked at this code, but we could look here. There's a thing called code view write struct. That's just the forward declaration, as Josh's comment says, and then we say scope.members, and we make type indices. We skip constant declarations or things with import links. So we're making the type indices. Okay, you know what? This is already wrong. I think. Let's see. So we make these type indices for all the members. We could actually break for a struct like okay, you know what I think happens? I think when there are substructs, something weird is happening. Yeah, guys, if there are substructs, see, I think this is incorrect in some way. If you add a new type while you're in the middle. Like this whole thing about automatically sometimes incrementing the index is like ass. I don't think that's correct. I think I need to actually look at this code. Okay, let's go to the new version. I think this is just confused and broken and never was tested very well, is what I think now. Because the things that I don't like about it seem like the kinds of things that would cause this problem. So when you say code view write struct, we return a U32. All right, let's look at what we return. Oh, we do increment. Interesting. I thought it didn't. Okay, hold on. What flags do we actually use here? Has unique name. Forward ref. So the rest of these flags are just informational. Boom. Lines of code win right there. Bam. Cheap one, but there you go. So this writes a declaration for a struct, and it does increment. So we do some members. This writes members out. Okay. In case those members do recurse, okay, wait. I did update, right? Yeah. See, this is very messy right here. Like, that shouldn't be a thing. Like, okay, so auto forward declaration index is this, and we're going to set slot pointer to that. Now, I don't know that. So we set that, we do things, and then we'll return the non-forward declaration, which will actually be stored in the array and will be used henceforth. Okay, so we make these type indices. This is wrong. What are you doing? This is wrong because we're sizing the type indices by how many members there are, and then we're skipping some members. That is ass. This is a reserve, and this is this. But then how do we know which declarations those corresponded to? Yuck, dude. Oh my God. Okay. So then we're iterating again, and we're using these type indices along with names. And this is not even the same skipping code as this. If these desync from each other, you're fucked. So you're fucked. Okay. So what we have to do here is we'll say declaration and code view type. Declaration and code view type. There's just certain kinds of code that are error prone and will decay over time, and there's certain kinds of code that are less error prone and will be less prone to decay over time. they try to teach you what those things are in school, and they do actually get some of them right. And this is one of the ones that you would learn in school or from Uncle Bob or whatever, right? And you just shouldn't take it to extremes, but this, it seems a little bit bad because we're paying a little bit of a performance cost, slightly more here because I'm storing more data, but it's negligible and the code will just be better, right? So what's happening is as we decide what declarations to output and we get a code view type for them, then we're going to store the declaration and the type so that we don't have to make this decision more than one time. We could also have factored this out into a function, but that's still, I don't like that as much for this purpose. So I'm going to say type.add, dact.declaration is decal, dact.codeview type equals this ting-tangler. Okay, so there we go. So we're just making just a little array locally here. We already were making an array, so this just has more bigger element size, right? Okay, so that's fine. So next, down here, instead of iterating this again, we're going to say for declaration and code view type. I'm just going to comment this out for now so we see what it was. Declaration, decal, right, and then this is it.codeview type. So once we've associated that declaration with that type, they stay together. We're not like guessing later. And then we don't need this member count because member count is declaration and code view type number of items. Oh God. What is this right field? What is this last argument to right field list member? We're going to have to figure out what it's trying to do something different on the first entry. All right. But anyway, this is this. Okay, so now what is declaration and code view type? Well, it's what it sounds like. So just that. This is something that's actually, let's search for where code view starts, because this is going to like go into its own file later, I think. Code view and dwarf are going to get split. Anyway, this is something I'm doing a lot more. I used to be a little bit allergic to adding more structs in earlier iterations of my programming style, but now in cases like this, I'll just make a new one. Especially if it's not really a new thing, if it's just putting together old things, I'm totally cool with it. Okay, so now we still have this member count is equal to 0. So what is right field list member? The great thing about this is struct debug info was already screwed. So what's the worst that could happen? I guess we could break it even worse. First is not even used, right? It's like when you're on YouTube or a message board or a BBS in the 80s and people say first. Well, it's pointless to do that, as everybody knows. So now we're getting code simplification from not having to do the first thing everywhere. which doesn't count in our lines of code count, but which we are happy to take. Anything that reduces the codes is good. Okay. Is it just you that reacted to the Dacc.declaration equals whatever? What did you think it would be? Did I do something bad there? Oh, this is a pointer, by the way. Oh, this is, I guess I should do this. First, you thought you were missing some. No, there is no C++ magic there. That is a struct, and we are assigning. Oh, because I was using the dot for by value. Gotcha. No, that was just me not using the arrow because I'm used to languages where you don't have the arrow. Okay, great. Come on, bro, start up. This laptop's such a drag. Or did we break? Oh, we're broke already. Okay. Source. Well, we don't really see any more than we did before. So that didn't really solve our problem. I do feel much better about what's there now. So my proposal now is to look over what's there a little bit more. And if I don't see anything obvious, then what I will do is break there when the name is particle source, and we'll just see what it does, right? Code view right struct. Okay. So again, let's look at this. We collect our members. I'm just going to put these together. For readability. Actually, we don't actually care about the index, right? Well, we'll do that. That's fine. So for the scope members, we do these things. We look for these declarations. Okay, then field index, field list len, we add some stuff. Like, okay, here's what I don't get. What is this? Like, why are we allocating? This is every time we bump this pointer, we're allocating another type. And I guess that's because we're writing this field list thing. I guess the field list has its own type index. Like, this should really be like field list index. We're going to have to verify that later, but that seems like what that is. And then we write field list member. I feel like this is maybe the wrong unit of measurement or something. So this is telling us how much is in the field list, right? And this field list len, this is actually length before field list. So we're saying, what's the current length before the field list? -2, but maybe it should be -4. I don't know. But anyway, we're going to assume that -2 is right. Oh, I see. Right. I guess that's fine. Code view leaf structure, number of fields, property flags, field list. So that, yeah. This seems. In web, you would much rather have good architecture and sacrifice some performance for that. But none of these web systems have good architectures, and they don't sacrifice some performance. They sacrifice like 5 orders of magnitude of performance. Like, that argument doesn't make sense when neither end of it is actually true anymore. Just don't excuse these systems. They're the worst things in software. It could be worse. Well, I mean, it gets worse every day. So Just sit back. It'll be worse, of course. You aren't teaching architecture in university anymore? Maybe it's not a good school. Forgot to delete the auto it line. The auto it line. Oh, this line. Oh. Well, that wouldn't have compiled anyway, I think. But yeah, thanks. Five orders of magnitude is not a political soundbite. That is actually accurate. At least. It's probably more than 5. If you don't understand that, then you can't even have this argument. It literally is that much. Okay, so this was field list index. Out type. That's just a standard C++ compiler being dumb. All right, so I didn't fix anything. So I don't like the fact that this code doesn't work very well. So this is going to turn into make it work better. And I wonder, so it could be A, just this code is doing something obviously wrong. B, it could be some idiosyncrasy of code view that we're not handling correctly. Or C, it could be somewhere in between where it's just code view makes things complicated and we're not really handling those complications very well. It's probably that last one. Five orders is that big O notation. If you don't know what 5 orders means, you don't have a computer science degree. All right. Used to eat pointers for breakfast? If you think the fact that you do pointers is impressive, you're in the wrong place. I don't want to start a dick measuring contest, but seriously. All right. What do we have snack? We have slightly stale trail mix from Rembrandt's Coffee House, which would be better if it weren't stale. It is aged. It is finely aged like a fine wine, like Rembrandt's paintings. They also have this one with M&Ms and stuff in it, and it's like really sweet. I don't know how they did it. Like even the nuts are really sweet. So this whole thing about like it's for web, not for games, I don't like that line of argument because it's like if you applied that to anything else, you would just get laughed at. Like I'm even trying to think of something like there's no equivalent in the real world. Like, oh, you know, this motor is for go-karts, not real electric cars that go on the freeway. And it's like, okay, right, but why Why are you building go-karts and why are you defending go-karts? Like, it doesn't make any sense. That's a bad analogy, but I can't think of a better one right now. It's just made for kids as a sort of equivalent. Yeah, but kids are not supposed to be adults, right? Okay. So I guess I'm just making sure I didn't screw it up even worse. I didn't, but it also doesn't totally work. So let's see if we can tell what's going on. If I can't, then maybe we'll go to enums, because maybe that'll be easier, because enums is not working and doesn't have this recursion problem, right? And so if we figure out what's wrong with enums, maybe that'll be something about code view that I'll understand that'll help the structs click. But first, let's just do the step through thing. So when we get a struct, here we're going to say I think it's called name. Is it particle source? I don't even remember. Particle source. I don't think we have an overload of strings. I don't know. I don't think we have that overload. Bound name. So we have new string, new string. Okay, well, we can do it this way, I guess. Do a debug build. Set our breakpoint here. We're just going to see what happens. I mean, so the thing about all of these, like, I don't even know exactly what solid is, right? But the thing about all of these ideas of how to program is they're probably better than nothing. Like, if you didn't know anything about how to program and you wanted to start somewhere, it's probably better than starting in a void in like 1950 and having to figure something out. Maybe, maybe not. But like, I can't recommend any of them. Oh no, what? Oh. Like, none of them are what you actually want to do when you're good, right? So you should be looking at these techniques as things that help you understand programming and then that you leave behind later in favor of your personal style that you've developed through experience. That's not to say that they're all equally good, because they're not, right? In fact, a lot of them are awful. Oh, I should also put a no check in here. But you definitely shouldn't look at any of them as, oh, there's a right answer to how to program and this is it. That is not how it is for any of these. Okay. So we're here for particle source. This part is probably fine. Let's skip to the end and see. Oh, wow, dude. This actually makes me a little bit scared that this is where we are writing this struct for the first time. Okay. Pointer to, what is this? This is a struct. It's got a pointer to a struct, pointer to, hold on, what is this? Level set. Okay, so let's get our thinger here. Okay, so level set. Okay, wait, back here, context, level set, pointer to entity manager. Oh, this actually makes sense. Pointer to by type, pointer to. Actually, if we wrote this out in the order that the typo info exists, we wouldn't have all this recursion, I don't think, by the way. Maybe some, I don't know. We'll see. It wouldn't be this bad. This is array of pointers to. Hold on, I skipped. Particle source is here. Oh, so we broke here, and then when I said run to cursor, we actually recursed in further. All right. And we're down here in particle, because particle source, okay. So this is all actually correct, even though it looks like an infinite recursion. This is fine. We actually want to go. Okay, we're back at particle source. 116? Oh, well, I guess I kind of believe that. Let's make sure that doesn't happen again and confuse us. Okay, so we've written out all subtypes, hopefully. Scope members being 116 is a little scary, but I guess I believe it. Oh, because we're using a bunch of stuff from entity, right? Okay, so declaration and code view type 65. Let's go see if that looks approximately. I mean, yeah, that's probably about 65 things. I believe it. All right, so so we do that. We get a field list index. We get a start of the field list. For each of these, then we say name. Entity. Okay, that one works. And then I think we don't get anything else. So maybe something about this screws up. We know the base address is right because we can open it and stuff. This is a little bit scary. Like, we're not passing the concatenator directly. We're like having it figure it out again, which is skeezy because then we're checking it here. This is pretty bad, honestly, but let's see. I wonder if enums use field list as well. I bet they do. I bet they do. Okay, so this one actually works. We should pass that down. That's bad news bears. I think, right? Hold on. Let's make sure it's the same one even. 4C0, 4C0, yeah. So we should pass that as a parameter. This is very messy and is going to break later. I don't know what this 3 means. That's something in code view probably, right? Leaf member, 8 bytes, and then an integer. Is that an 8 byte in it? Like what? Wait, what? And then a name. I bet this padding is broken or something. That doesn't seem right to me. Maybe it is. That is my candidate for most likely broken thing. Okay, guys. I think that is what's broken. Here's the deal, everybody. This actually changed meaning recently. Although it would have been today. There's a question of like, what is this alignment relative to? Okay. Is it relative to the start of the section that we're in? Is it relative to the whole file? I don't know. The meaning of this actually changed today because I mean, I guess the section's going to be aligned. But the point being, I actually changed whether there was data in front of this or not. Anyway, this is a little skeezy. Let's just, so we add some stuff, right? We add the name. It does get the name in the debugging info, so that's fine. So our alignment is 4 and start is 0, which I guess answers that question. Pause. It is offset. Remainder is 1. Like what? I'm gonna have to, like, this is by far the most likely thing. Like, it wasn't expecting padding, or we add it the wrong way, or we add the wrong amount, and then it doesn't see the field after that. Very likely to be the problem. this is kind of messy because we don't assert that the alignment is oh, no, yeah, we do. Okay. That's fine then. Here pad is 1 though. I think pad is off by 1 because code view leaf pad 0 see, we've added a padding byte here. Hold on. I bet we have to put pad -1 there. Not knowing anything about this format, that is my guess. Nobody on the internet knows what this is. Is that in here? LeafPad Linux. I will write to the author of LeafPad Linux. Field list. Ah, yes. Okay, this is also used in enums, which is probably why enums are broken. A field list is composed of 0 or more subfields. Because of the requirement for natural alignment, there may be padding between elements of the field list. This program walks down the field list. The address to the next subfield calculated by adding the length of the previous field. The byte the new address is examined is greater than F0. The low 4 bits are extracted and added to the address. Oh, so you don't subtract 1. They are not included in the count field of the class. Okay, so that's incorrect, I think. Hold on. I mean, we're including it in the field list length. But maybe it's just the individual member? Like, I don't know, dude. This seems very screwy and easy to get wrong. These padding fields are not included in the count field of the class, structure, union, or enumeration type records. If the field list is broken into 2 or more pieces, then the last field of each piece is an LF index, with the type being the index of the... Yeah, we're not doing that. Oh, that's what we might be doing for the forward declaration. But that's not the problem right now. Right? I don't think it's the problem. Okay. This does not seem super helpful. If it is greater than OXF0, we're going to have to see section 3.5 in a minute. Yeah, I think this part is wrong. But I don't understand what it should be. It says it's not in the field list count. Section 3.5. Okay, I can't find that by searching for section 3.5. Oh, there we go. Enumeration name and value, friend function, data member. That's probably what we're doing, right? Is LF member? No. Oh, these are spelled leaf. We're not using all these. Leaf member. Like, this, I don't like this. Like, I do like spelling things out, but when the documentation gives it a specific name, you shouldn't change the name. Okay, member. Member attribute bit field. Type. Like what? Wait, why are we putting a 3 in there? What? What? What the fuck is this? Like, come on. Okay. This is weird. Okay, this is another one of these problems that I keep having. This is not, like, CodeView had some weird thing where it was like 16-bit, and then they did the 32-bit version, but it's different. So here, this type is actually here. It's not what you see here. So maybe this LF member actually isn't the same. Hold on. Yeah, this is the 15.0 whatever the fuck. So let's see what that does. That's not even... Yeah. This is like the 32-bit version of whatever we're looking at, which is not the same, but I don't know if the 32-bit version is even documented. Length prefix name of the member field, that's fine. That's the add string part, and then there's padding. See, this is the frustration, is if I can't see the actual like, I don't know what this is. Here it says attribute for that one. But these both do the same thing, where they add the name and then they add padding. And for the enums, it would lose sync and then it would get sync back, because enum number 8 was correct, remember? So it's padding. And in fact, I bet if we make a sample program that has enum names in it, if we change the names length by 1 or 2 characters, it'll change where it syncs up again. Appropriate typo? What typo? Oh, maybe in chat. Have you worked in a code base that every time you change a single function, there is something broken somewhere else you had no idea existed? That kind of code base is a mess, and the priority should be to fix the mess. The problem is people usually don't even understand how to fix the mess, and so they just start to fail at that point. Okay. Well, maybe one of the other sources will say something about this. Okay, I fixed the code view write type info being insane garbage. I didn't go all the way yet. Okay, so this Microsoft symbol and type information, that's the document we have open. PDB public release. I don't know if that helps us. We can go look at this file and leaf pointer. No, leaf member 150D. There it is, LF member. Okay. There's like the ST versions and the whatever. See, this is under types with 0 terminated names. If that's the case, maybe that's actually the hold on. No, that is 0 term. Okay. There's going to be a struct in here for the members. I just don't know what it's called. On the basis of the type record base. This is why in most of the LF records that the CV type T is located on what appears to be an offset mod 4 equals 2 boundary, bro. Field list, which are aligned to their own bases since they don't have the length field. Field lists are aligned to their own bases. That is not what this code is doing. This code is aligning them to the top of the file. I don't know exactly what this is going to be a 64. Okay. Right, field list member is going to have, where did I put it? At the end. Damn it, bro. Oh my God. What a pain in the ass. All right. It's not that bad. Good thing we removed that other extra parameter so that we could add one, because otherwise it would be worse. So the question is, what is the base of the field list? Actually, is it here? I think it's here because of the -2s. Like, We do length minus field list len minus 2, and that's the length of the field list. So I think this is the base. That's just a guess. All right. Like the base is where you write the number field list. That is my theory. I'm sticking to it. We'll find out. Okay. Let's watch it be drastically worse. The 3 is cv dump type info.h define access public 3. Okay, thank you. Let's actually go to that file and name all these enums, honestly. Okay, wait. I didn't want to do this. I want to do this. cv dump type info.h. Where is cv dump in here? We had that, right? cv dump. I should probably download this and compile it because it seems like I would want to use it. Okay. Access public. All right. Wait, we even had it here. Oh no. It's defined there and we still didn't even use it. Okay, I'm going to use this name for now, even though we probably shouldn't be using these made-up names, right? We should use the official names, but we're going to do that for now. And then why does this have a 0 attribute? Like, what is 0? Access none. What does access none mean? I guess because it has no storage. Here we go. I hope I didn't delete something from here. Anyway, we were over here, weren't we? Did we run? I don't... Code view record is corrupt. Oh, no. Okay, well, rip. So I got that wrong. Do I add 2 to it, or do I subtract 2 from it? I don't know. Maybe I just got it wrong in one instance with leaf padding. I mean, I didn't do it for the enums at all, so there's that. I'm just going to try that for a second. That's also not going to work. It didn't, but I should be able to save the bacon by just saying it's 0, right? But it said they pad to the size of the field list. Which really confuses me. And that's why they appear to have an offset of 2, which would make sense because the size of the record is 2 bytes. So like the documentation is punking me right now, or the header file is punking me. You thought it was the mod of the size. No, this number that I'm passing in is the start, like where the record started, and then the size is the length minus start, right? And then this is modding by, the alignment is a power of 2, so alignment minus 1 is all 1 bits, and ANDing with all 1 bits is the same as modding by that number, all right? So, if you're trying to do alignment 4 and your remainder is 1, you need 3 0 bits. So you take 4 minus 1, which is 3, and then you say, hey, we're padding, and then you add 3. Now, this doesn't make sense to me because, like, oh, I guess it does. First padding byte and then the next padding bytes. Okay, I get it. It's a little confusing. On the one hand, I do think it is a padding problem. On the other hand, maybe it's not. Because when we mess up the padding, it says, hey, corrupted file, right? So why wouldn't it say that if we messed up the padding normally? So maybe the problem is something else. But maybe not. I don't know. So maybe, I don't want to do this tonight because it's getting toward bedtime, but I could like download and compile CV dump and then run it on the frickin' thing and have it go to, particle source and see what it actually does. If it goes that far, I assume it'll go that far into investigating, right? So we can see what it actually does when it's decoding that thing, and then we can see what's wrong. It's just, that's not the level of investigation I want to do tonight. Or not anymore. If it was the start of the night, I would do it. Wasn't the padding stuff here? P equals padding added. Change log for 16-bit to 32-bit type and symbol records. God. Just make your file format big enough to begin with, all right? All these things would be half as complicated. LF enum doesn't have padding added, although maybe it had padding already. I don't know. What is LF member? Also doesn't say padding added. But we know that members have padding. I don't know, dude. LF member. All right, here we go. This is what I was looking for. Attribute, index of type record, and the name. Enum props are different and don't have an access. So it's just an empty field there for enums. Oh, maybe its internal padding must be 0, right? No, it says access. Padding. Which file had the note about padding? Was it here? Dang it, bro. Was it here? Where was the thing that said padding to the base of the record? I don't even know where it was. Oh my God, knowledge has been lost. Civilization is now collapsing. Right above changelog for padding, really? Oh, no, it's called alignment, not padding. On the basis of the type record base in most of the type records. Which are aligned to their own bases. Wait. The records that are in a list are aligned to their own bases. So that doesn't mean we pass the field list start. That means we pass the field list item start. Which would be great because we would be able to get rid of this field list base. All right. All right. And what is this code view write integer? What is this supposed to be? I guess I forgot. Offset. Oh, okay, just the offset of the... Oh, right, that's how far it is into the struct. Dir. Okay. Okay. So field list base is going to be this, and then... we're going to get rid of this. This is also not going to work. But you have to try. You got to try. It did work. Will it do anything different? Maybe. Maybe. Okay. Well, it's behaving exactly the same as before, which is what I would have predicted. So I think what's happening is these things are coming in 4-byte aligned because everything else is aligned. Oh, but that doesn't make sense. That doesn't make sense. Okay, I want to make a test case because I'm not really sure if it's alignment, right? So I want to try to make a test case to convince me that it is alignment. All right. So I'm going to make an enum with all 4-byte or 3-byte member names, right? So words is an enum with hey, you, guy, get a job. All right. Now, I think that should actually come out, right? So are we making debug build? Yes. Okay, get. So now we're going to go here. We're going to go session. Oh, it's in subfolder. No? No? What's going on? Program halted with exit code 0. Is it not called that? Let's, I don't know if we rename main or not anymore. All right, let's just do this. No. Is it even running? Like what? Oh, we got to recompile it. Oh, that's not x64. Duh. Because LLVM does stupid stuff. All right. So here we are. What are words, right? Okay, it's not. That's weird. I would have expected it to be fine. Here's what we're going to do. We're going to have all of them and then see it in local, right? All right. And my bet is that hey is fine. We will see hey, and we won't see you because alignment's messed up, right? So actually we could just do this so that we're in the right stack frame. Locals. Yeah, see, we have hey, we don't have the next thing, which implies to me that the padding is messed up. But that also makes me think that if we make that name the right number of bytes, we'll magically align, or maybe the padding will always mess it up. But it was weird because with the enum in the game, it did eventually resync. But actually, that way we don't have to name it. There we go. If the name is 4 bytes, then the next one is fine. All right. So then here, then we get to guy, right? And if we say, hey, use guys, then we'll get even one further, right? So this is really weird. But yeah. Now it's writing the 0. These are 0 terminated names. So why would 5 bytes be correct? Wait, maybe 3. Okay, I was assuming that 4 is exactly right, but maybe 5 is also right. Maybe the problem is when we are a multiple of 4, of 3 plus 1 0 byte, because then we don't do any padding, and maybe no padding is not allowed. Maybe if padding would be 0, it has to be 4. That would be kind of stupid, but maybe that is. So like, what if we put 2 underscores? It's like wearing 2 layers of underwear. It's still fine. Okay, here's my theory about what fixes it. Ready? Are you ready? Are you ready? Ting tangle. Nope. Wait, did that get worse? Oh, okay, hold on. This is really weird because it desyncs and resyncs. Hold on. Did I not see that it desynced on the second one? Hold on. My theory about the solution does not seem to be right. I was going to feel real cool there if I was right, but I wasn't. No, what? Was? So I kind of don't have a theory now. If it's 3, we desync. If it's 4, we don't. If it's 5, we don't. I mean, the pattern would be 6 and 7 work and 8 doesn't. There's 6. Six doesn't? Wait, what? Was? 6 doesn't. 7. I mean, whoops. Now I'm running the wrong things. Dogs and cats living together. Okay. This is getting banana nut balls. I do think it's about alignment, but I don't even... This is like one of those Mensa tests that the smart people take about what's the pattern with these numbers. And then I don't even pass the Mensa test because I'm running the wrong program to begin with. That works. I don't even... Does anyone in chat see something that I'm missing here? Like, what the hell? What happens when no zero term gets called with -1 because pad is 0? Oh, it won't be 0. So, pad is always alignment minus remainder, and remainder is always less than alignment. Strictly less. Oh, well, except for when I took this off. It's a good point. Let me try this. That's a good point. I don't think this is still a thing, but okay, I screwed up real bad. What? What? If no remainder, remainder equals alignment. Oh, but then, okay, right. No, okay, this wasn't a problem, right? No, it was fine, because if remainder is 0, pad is non-zero. That's what happens if you pass -1, by the way. Which one did I say is more difficult, the language compiler development or game development? I mean, it depends on the language or the game. I think game development is definitely harder, but if you make a really simple game, then it's not harder, right? You don't have a test for a words.hey. What do you mean? You're very scared by the fact that PDB dump doesn't skip padding in a sane way consistent with the documentation. Well, PDB dump was probably copied from Microsoft code. So PDB dump is probably right, and whoever wrote the documentation is probably wrong. And so maybe I need to look at PDB dump, right? I have a words, b words.u. Yes, that is correct. The default value of a will be the first, or the 0 value of the enum, which is hey, which means I can change the name without having to change it down here. But you'll notice every time we go to the debugger, this is the value of that. If not remainder, then you don't write code view leaf pad 0, which is what? That's just the padding signal. The documentation says you skip to the end of the record size And then you look at the byte, and if it's higher than this number, then you skip that many bytes. All right. Do we always need that even if no remainder? Well, in theory, no. Because in theory, if you don't write this, I mean, this is the weird thing, but I'm pretty sure the next byte has to be a record type, right? So it'll be less than code view leaf pad 0. Something like that. If you're reading into this code correctly, it's expecting something like LF pad 3, LF pad 2, LF pad 1, and not zeros. I see. So you should be able to seek to a random byte, and that will tell you how much more forward to go to get to the next record. Does that sound correct? So I should do something like this, like while pad add a byte pad minus minus, right? Like that. People are yelling right outside my door. Sorry if you polluted chat for a while. I wasn't paying that much attention. I'm pretty sure I would disagree with what a lot of people were saying about how to program, so I just ignore it. Is alignment always a power of 2? Yes, this assertion makes sure alignment is a power of 2. It's literally just skipping pad bytes, but not 0 bytes. Yes. Okay. So basically, it will skip as long as it's higher than pad 0, right? Like if it hits something higher than pad 0, it just keeps going forward till it sees something less. Is that what it does? I don't know. I mean, let's see if my interpretation. Hey, we win. It never decodes the bits, yeah. We're going to write it out that way anyway, just to be special, but okay, so I mean, the thing is, padding basically doesn't matter on modern CPUs anyway, so I wonder if we're just allowed to not have padding. You know what I mean? Like, we would get a smaller file. All right, that makes me happy, because that is a feature we can ship to our people. I mean, let's go back to the game, right? That's been broken the whole time, I think, and I just didn't do enough debugging in x64 backend. Or no, I noticed it a long time ago, but figured, hey, it's early and a little bit unstable. Um, so let's go back and break in barred particles. Barred particles. Okay. So source, hey look, we could see all the members. These are probably getting weird type indices that it doesn't like. Like these are void, so I think Remedy doesn't like it if you say something is of type void. But everything else here is all working. Look at all these fine members, 65 members of the struct. It's crazy. I can see things. Well, that's null, so you can't really see that, but these things are not null. Look. Look, it's random variables with different 3 dice. Do you still execute the bytecode with a bytecode interpreter? Yes. We may someday use native machine code, but we don't yet. So it was working with 0 to 1 padding bytes, but not more. Yeah, probably something like that. Probably something like that. Except, no, because there were longer lengths. Well, I guess if those lengths happen to work out to 0. It's just I expected a pattern like that, but it didn't exactly look like that to me. So I was a little confused. Like as I made the name longer, I expected to see like, oh, it works at 3, it works at 7 or whatever, or it works at 4, it works at 8, but it worked at 4 and 5. So then I was like, what? Like, why does 5 work? Three dice. 3 dice. Thanks for the help, by the way. That was very useful that you looked there and saw that because, I don't have a lot of... So everybody has things that they're very effective at, and everybody has little personality flaws. They're not even flaws. It's like, okay, everybody who's effective and successful has developed strategies that let them be effective and successful, but no strategy is perfect, right? My strategies, as you may have noticed if you watch the stream, is I don't like to rat hole on other things. Like, I don't want to get lost in some maze at looking at a bunch of different, like compiling other programs. I don't like using tools, right? And all that. And so what that means though is I really don't want to like compile a C program. I never even compile new C programs because like I just use Visual Studio in the same C++ thing all the time. I don't even remember what the arguments are to compile a C program. I don't even know if I have a shell with the C compiler in the path by default. Like just going down that series of things is so painful for me, so I don't do it. But that probably would have been the most effective thing to do in this case, as demonstrated by that Jacob Lee in chat just decided to go look at PDB dump and see what it did, right? And maybe I wouldn't have had to compile it. Maybe I could have just looked at the source code and seen that. But yeah, like that is a thing that my personal strategy, has weak spots there. That said, I don't know if that means that those weak spots are fixable. Because sometimes I don't know. Like like the whole reason that I'm making this language is because I'm super frustrated at tools and just crappy stuff, right? And so if I had more of a tolerance for crappy stuff, maybe I wouldn't be doing this at all. You know what I mean? Like it's but anyway, worth saying. But yeah, thanks for looking that up. That really helped a lot. Um, I am kind of tired now. It's after midnight. I'm slowly getting more and more on Tennessee time. You know, I've been 3 hours ahead, and I sort of have been staying up late and doing streams till two a.m. and stuff. The problem is, like a lot of places I would go to work in Tennessee here, like coffee shops and stuff, a lot of them close pretty early. I think also because of COVID, like they don't have as many customers. So a lot of places close at 5 p.m. or whatever, right? So like if I don't get out of the hotel till 12:30, I don't have that much time that I could like chill in a coffee shop working. You stood out because the code was not doing what you expected, so you spent a while staring at it. Yeah, but like I never even got PDB dump open in a web browser, right? Because it just wasn't the way I went. Maybe I should have, right? I mean, I sort of had other parts. I think PDB dump is in this Git repository, right? It's one of the programs. Yeah. Of course, I don't know why PDB dump and not CV dump, but whatever. Anyway, though. Okay, I should at least say padding in code view does not seem to quite work the way the header file implies. PDB dump skips forward until it sees a value less than or equal to code view leaf pad 0. In theory, we don't need to write the number of pad bytes remaining, but let's just do that anyway. Because PDB dumb. It's just B and P, they're the same letter. I mean, they're just flipped. Come on, guys. It's less than pad 0. Really? Then the documentation is super wrong. Because the header file said, I swear the header file said greater than or, let's see. Where was it? Where was it? No, I don't remember what. I don't remember what we saw. Pad 15. Yeehaw. I don't remember what said how LFPad was supposed to behave. Yeah, PDB is just rotating the same letter around, dude, and flipping it. Why isn't there a Q in there? I'm going to make PDB Q. It's going to be the awesome format. PDB quantum. PDB quantum. All right. Well, I'm very happy that that works. We can put that in the change log. X64 debug info now correctly shows all fields of structs and well, we still okay. That thing about XY vector stuff is not fixed. We'll have to look at that in a bit. That's probably also broken on LLVM, maybe. All fields of structs and all values of enums. That's going to be a good update. What did I just tell myself? I was going to go here and make a note. Oh, vector and place in debug info. We need to figure out what to do about that. Maybe we just put all of them. Did I need to align to the base after all? It didn't seem to. It does say greater than OXF0. Yeah, like people just are not paying attention. Either the author of PDB dump wasn't paying attention, or the author of, like, I don't know, man. Why was there a bitwise and with the alignment -1? Because you're modding by the alignment. That's a mod by alignment. Oh, that one. Sorry. Sorry, debug writer. This one is the mod by alignment. This one is just making sure that it's a power of 2. If you don't know why those are each, then it can be a fun exercise to figure out why. And does mod for very specific cases only. LF pad 0 is an unusable constant. Well, the thing is, like, it makes sense if the reason it says less than or equal, I'm sure, or whatever, is because that is supposed to tell you how many bytes to skip, is what that comment said, right? So pad 0 would mean skip 0 bytes, so you shouldn't ever write that because it by itself takes a byte. That's what I was confused about at first. I was like, what? Right? So pad 1 would mean skip 1 byte, pad 2 would mean skip 2 bytes, and so forth, right? But pad 0 should never exist. Which I guess is another way of saying what you just said, now that I read it again. Well, that's pretty successful. I had actually hoped to do more performance things than we did, but we fixed a very long-standing bug. That's probably been in there. I mean, some of the comments on this were written in 2017, so this has been broken since 2017. So that's great. Let me tell you what I want to do for low-hanging fruit for next time. Because we could do the step 2 where we blast through all the debug types in the beginning and write them out. I think that would be good. However, maybe not so easy as I thought, though. We'll have to do some testing to see if that's viable. But anyway, there is this thing called modify that gets called on the concatenator all the time. Like this field list thing that we were looking at. And this is very common, like you have in a file format. Hey, here's a couple bytes that say how long this field is. But you don't know how long the field is if you haven't packed it yet, right? And so very often what you do is you say, record the location, and then write a bunch of bytes. And then when you're done, go back and say how long that was, right? And put that in there. And then whoever reads the file will know how long it is, right? Very common in many file formats that aren't crappy JSON stuff that you should never use. So when I was writing this code initially, I was just being really paranoid. Like, I didn't know. I wanted to be really safe and robust, and I didn't know how things were going to work out. So I made this thing called modify 2b, where you just put the byte index, right? This concatenator thing, which is what this C arrow is, it's basically just a bucket array where each bucket is probably 64K, and you write data in there, and when you fill it up, it allocates a new bucket, right? So it's just a way of minimizing allocations and also letting you build up a really big file without having to like recopy it all the time the way you would if it was an expanding array, okay? So far, so good. The problem with modify 2b is once you start getting farther into the file, well, let's just say it has to look for what bucket this position is in to find the memory location, right? It has to traverse. And that doesn't sound that slow because maybe there's not that many buckets and stuff, but you're pulling all those buckets back into the cache. And if you're doing something like every field of every struct, or if you're doing that for every variable in the program that you're putting into the debug info, that starts to be a lot. It starts to be thousands, right? And that can be noticeable on the execution time. And so what I want to do is go through and replace all of these modifies with just taking the pointer to the memory and then stomping that pointer later, right? Wait, why can you take the pointer to the memory? Well, because this is a bucketed structure and doesn't resize, it doesn't move. And I did have this thing before. Remember earlier, you might have seen in the stream, there was like an add function that I said was slow because it was doing a copy. If we never use that, and we steal the buckets, the advantage of stealing the buckets, besides the fact that you're skipping a copy, is that the memory doesn't move, so pointers stay valid. So you could actually steal buckets and then patch pointers later, which I don't even know if we need to do that much, but the point being, it's still valid. And so we end up writing out this big file with all these chunks linked together. We could patch it anytime. And so basically, these modifies can all be a lot cheaper than they actually are. And then this kind of stuff, all these adds, these are range checked adds, which it shouldn't be. Like, sometimes we do a thing where we reserve space and then we add U2B unchecked. Let's go look at that. So basically, if you add U2B, for example, that's 2 bytes. What if there aren't 2 bytes left? Then you have to expand the concatenator, right? So that's just like an if statement and maybe a function call and stuff, but it makes the code size a lot bigger. And, those if statements are not great. But if you know that the size is reserved in advance, then you can do U2B unchecked, which this is a thing that we do for debug to make sure you didn't make a mistake, but otherwise it's literally just inlines to that, which is much better, right? So I want to switch those too. Those, it seems like it wouldn't be that much, but when you call these over and over and over and over for many, many symbols, it adds up. So that is low-hanging performance fruit that I think I want to do next time. Will 2 bytes ever span 2 buckets? Oh yeah. Well, I mean, in this particular file format, it might not be possible for 2 bytes to span buckets because we're constantly realigning, but the data structure doesn't know that, right? BSON, is that a binary JSON? I don't even want to know, dude. You see the initial 0 output, make sure it doesn't do that. The initial 0 output? I don't know what you mean by that. But yeah, so what the unchecked things, you're only allowed to use unchecked when you've reserved enough space in advance to make sure that you won't cross a boundary, right? And then if you do cross the boundary, it's an error in debug build. So if you say, reserve 16 bytes and it can't reserve it, it just leaves the rest of that bucket empty and puts that 16 as the beginning of the next bucket, is how that works. BSON is exactly that. Well, RIP. I don't know why people are so stupid about formats. You meant that it doesn't force the bucket to be full. Right. Yeah. It'll probably be almost full, right? Because it's like the bucket's probably 64K. I mean, it's configurable per data structure, but it's probably around 64K, and you don't tend to reserve large sizes, right? I don't think we ever reserve more than like 32. So you're basically using the whole bucket. But yeah, this was good. So I think this beta is going to be the beta of x64 backend improvements. I think we're going to do a lot of x64 backend improvements because I want to get to a place where we actually start making the machine code output better. But before I do that, I wanted to make this better because there really are still a substantial number of improvements. Are we still code DKP minus? We should be, because I commented out all those frickin' enums. Yeah, we're like down. How much was it? 272. So we're down 15, but honestly, that doesn't totally count because we just commented out a bunch of enums as well, which are easy. But it is what it is. As long as you don't try to reserve an entire array in advance. Yeah, that would be misuse of the reserve, right? That would be bad news bears. When the syntax is redone, how are you going to reword original files into the new syntax? We'll give you a program that does it. All right, so we fixed long-standing bugs in debugging info. We managed to reduce by almost a megabyte our code view data size, and we took about whatever that is, 7 milliseconds off the runtime. So what I think I want to do next time then is just attack this number. This number should be a lot lower than it is. Let's just say that. So I want to drive that number down. All right, thank you everybody for coming by. It's been a good stream. We'll try to keep doing more good streams as time goes on. You know what? Let's just run the tests before I check. Before I just say everything's done. Look at all these no check-ins that we have. I'm actually not sure if we need to do this field list base thing. Because like it's probably aligned. Like if you align after every field, then we could just align to the start of the field, right? Explains why modify has to iterate. Yes, you can't just mod by the bucket size. But also, I think the buckets aren't stored in an array. I think they're in a linked list, so you would have to iterate anyway. I could put them in an array. Let's see. Yeah, I'm pretty sure. Yeah, it's a linked list of buckets, right? Now, of course, we could put those in an array on the concatenator, and that would make modify, well, it wouldn't really make it faster because of the variable bucket size. But if we got rid of the variable bucket size, then it would make modify faster, but I would rather do this other thing because it's even faster, right? I think we're just going to align to the subfield. Let's make sure it works first. But then I think we're going to change it to align to the subfield because it's like the laws of physics with conservation of energy. If it's conserved at T minus epsilon, it's also conserved at T plus epsilon. Okay, so this is working great. That's working great. I just want to get rid of this parameter, basically. So, padding. Oh no, we did already do that. Right. We padded to the start of the member. So I'm just going to do that. And then we're not going to pass it in because we're not using that value. Very happy about that. We got some lines of code back, only a little bit, but we got some. Okay, we're just going to run all this stuff that we did again. Boom. Can't help but feel like someone outputted incorrect padding once and then someone randomly changed the skip padding code until it worked just like we were doing. It seems likely. It seems likely. Well, that is a wrap. I think we got all the no check-ins. Very, very successful. Very successful. Fix names of struct members and enums in x64 debug output, period. Tang, tang, tang. Am I still looking to move to Tennessee, or have I given up looking there for now? I mean, I would consider moving here, but I'm kind of right now like not itching to move immediately, right? I'm just like chilling, looking around, that kind of thing. Are there any other options I've considered? Well, I looked around in Texas, but I didn't totally love Texas. Any final questions about what we did before I go to bed? Vegas. Well, I do know some people there. How's this going to affect the company? Didn't have trouble managing it from Seattle? Yes, but at this point, it's not even legal for us to run an office in San Francisco right now, and we don't know when it'll be legal. So we just have to deal. Yeah, it is still illegal in San Francisco for non-essential businesses to be open, which is crap. San Francisco is going to go out of business, and they deserve it. Come to Tokyo. Tokyo is really nice in a lot of ways. I really like it in a lot of ways. I just, I'm not really comfortable in a place where I don't really speak the language well, right? Which of course would fix over time. That's fine. I'm actually good at learning languages, so that's fine. I'm also pretty good at not having a terrible accent, although I don't know. Maybe not anymore. Anyway, I'm good at like noticing what I sound like, I guess is what I mean. But I don't know if I could live in Japan. Just Japan, all of the crazy social rules are just, I can't deal with it. I just, despite all the good things about Japan, I don't want to live there. But I really enjoy visiting Japan. It's a great place. Do we allow pointer aliasing between arbitrary types? Yes, currently we do. I haven't really attacked the aliasing problem very seriously yet, but I don't like that C++ style solution to it, so I doubt that we will go that way. But we'll see. Like, I honestly don't know. Yeah, trying to run a business in Japan, I wouldn't want to do either. All right, thank you, everybody. I'm going to bed. It's been great. We'll do some more of these soon. Bye bye. Oh, I should stop the stream. Bye bye.